Right. Hope this is recording. How is everyone? Good morning. Happy Wednesday. We're halfway there through our first week of Distant Learning 2.0. Let's get to this warm-up activity. It says, evaluate the following radical expressions. The first problem is the third root of x to the 12. The second one is the square root of x to the fourth. And the third one is the fourth root of c to the 8. All right? Let's do number 1. All right? Number 1. Today is 13, 14, 15. Today is 11. Jesus. What's today? Today is the 15th of the 4th of the 2020. All right. Well, it looks like 28. Sorry. All right. Let's use pencil. All right, so number 1. The third root of x to the 12. Cool. All right. What is this problem asking for? I'm asking for 3. It may be helpful to set it up like this. 3 terms that when multiplied, 3 like terms, that when multiplied give you x to the 12, right? So we know they're going to have to have x because you want to end up with x. So then I know definitely what's going to go in these boxes is x, right? But x to the what? X to the what? What do you think goes up there, right? So 4, 4, 4, right? So x to the 4 times x to the 4 times x to the 4 gives you x to the 12. The rule that we're using for this is x to the a times x to the b is equal to x times a plus b, right? So when we're multiplying 2 terms with like bases, you're just adding the exponents. So x to the 4th times x to the 4th is x to the 4th to the 8th, and then plus another 8, another 4 gives you x to the 12. So why are we doing this? Because the answer for the third root of x to the 12th is, I'm still in pencil. So then the third root of x to the 12 is x to the 4. All right, let's go to number 2. Number 2, a little easier problem, I hope. So this is the square root of x to the 4th, right? So there was 3, so we were asking ourselves 3 like terms that when multiplied give you the what's inside, the radicand. Here, there's nothing. Remember yesterday we said if there's nothing there, we're assuming that it's 2, right? So here we're asking ourselves 2 like terms that when multiplied give you x to the 4th, right? So we know it's going to have both of these are going to have an x in it, right? It wouldn't. We're trying to end with x. We can't say this x and y, right? Because x and y won't give you an x. So x and x, just the way it is, x times x is x squared, but not x to the 4th. What do you think have to go up here? What is the exponent? You're right, 2, right? Because x to the 2 times x to the 2 is x to the 4th. And the rule, again, that we're using is x times a times x to the a times x to the b is equal to x to the a plus b. So like bases, all you're doing is just adding the exponents. All right? I'll make up a table. I'll write a table where you can refer to all these exponent rules, right? So back to this. The square root of x to the fourth is x squared. Cool. Third problem. The fourth root of c to the 8. We're just using a different letter, right? So here we're asking ourselves, instead of three like terms, instead of 2 like terms, here we're asking for 4 like terms. So we use squares, we use triangles, let's use a circle. What times what times what times what gives you c to the 8? We know that it has to have all c's, right? So what do we think is the power of each one of these? 2. Right? Because all we're doing here is just putting the exponents together and putting the bases together and adding the exponents. So you're putting the exponent together and adding the exponent. So 2 plus 2 plus 2 plus 2. 2 plus 2 is 4, and then plus another 4 is 8, right? We're using this rule up here again. We're using this rule up here again that we've been using for the past 2 problems, right? So when we're asking the question again, wait. C to the 8, the fourth root of c to the 8, that is equal to c squared, because c squared times c squared times c squared times c squared is equal to c to the 8. All right? I hope that makes sense. If you have any questions, please email me, call me of this. Is there a shortcut? Yes. I'm going to do it in purple. All right? Actually, I can't do it in purple. Oh, no, yeah. Okay. I'm going to do it right there. So what's another way that I can rewrite this third root? I can rewrite this third root as x to the 12, right? But this third root, I can also rewrite it as to the 1/3, right? So using my exponent rules, I can also say that x times 12 to the 1/3, right? And then 12 times 1/3 is x to the 4th. So gives us the same answer, right? So it's just knowing how to rewrite our radicals, right? So using the same approach, using the same shortcut, I probably shouldn't name it shortcut. I should probably name it a different approach, right? Because depends from person to person. So using the same approach here, let's rewrite the radical in a fraction. So on Monday we saw that if it's a 2 or if it's a 3, just put it as a fraction like we did here, right? So again, x to the 4th, all of that to the 1/2, right? And let me zoom in. No. Oh, here. Sorry. Yeah, there you go. All right. So this is again 4 times 1/2, and then 4 times 1/2 is equal to x to the 2, and that's the same thing that we got here. All right. And then similarly over here for the fourth root of c to the 8, rewrite the fourth root here, c to the 8 to the 4th root. Let me zoom in. And then c to the 8 times 4th. And then 8 times 1/4 is, you got it, c squared.